Konnichiwa. Thank you very much for taking the time and arriving for this event. I would like to personally thank Robert for inviting me, coming all this way, but I see a room full of people, and I hope that we'll be able to work and teach and learn from all of you. My name is Rafi Glickman. I work for a relatively small startup in Israel, which is called Sqream. Sqream is a company that does one thing very good. We know how to run SQL queries on a GPU database. This is why we call ourselves GPU-based database. A little bit about the company. We are a company of around 83 people already. This slide is not updated. About a year ago, we were only 23 people, and we are growing very fast. The reason we are growing very fast is that data is growing very fast. And companies are looking for very fast storage, very fast and good file system, but also the best way to run their queries and get the best performance. A year ago, we received investment of about $30 million from Alibaba Group, who chose us to be there for their big data. And we used this fund in order to start our offices in New York and in order to grow our business in Israel and development and R&D and the like. What am I going to talk about? First, I'm going to talk about how much data is growing and what is the importance of analyzing data. What is the business value that your customers may gain when they are analyzing data? What is the challenge they face today? Everybody understands that analyzing data can bring them a lot of value, but what are the challenges customers face today when they want to do analytics? Why the existing solution that they have, especially Dupe, I believe Dupe is very popular in Japan as well, are very challenging. We'll see what is Sqream value proposition and some interesting case studies that we have around the world. So the first thing when we started our company was to realize that the amount of data in the world just keeps growing and growing. And if we want to deliver a new kind of database, we need to change the mindset. And we cannot rely on CPU technology, which is not running so fast. And we decided to make all our bets on a GPU technology. GPU technology, especially NVIDIA GPU cards. The reason is that GPU technology is growing today much faster than the CPU technology. And in order to meet the big data challenge, we develop our technology to run on GPU of NVIDIA. When we meet customers, they tell us the following. We have a lot of data. We want to take this data, do analytics, and get out of the analytics insights that will drive our business faster, that will improve our margin, that will help our operational cost. The only problem is that the more data we have, the more sources of this data we have, the more information we put into our system, we have to spend tremendously amount of money, and the things become very, very complex. We like to look at data as the new oil. In the past, in Israel, we say, if you had a lot of camels, you were a very rich man. I assume in other countries, you may say it's a lot of land. But today, if you look on the big companies like Facebook, like Google, they have a lot of data. And they are able to make this data the new oil. They are able to take this data, squeeze this data, and generate a lot of revenue. The more data they have, the more reporting, the more analytics, the more action, the more value they can have. The only challenge they have is they have to make sure that they are able to crunch all this data, that they are able to query this data, that they are able to get business insight in a reasonable cost and time frame and complexity. When we meet customers, they tell us we have lots of data. We want to become data-driven organization. We must take decisions based on our data. We have lots of data, but we only analyze about 10% of it. And the reason is our systems were developed 20 years ago. We have DB2, we have Oracle, we have MS SQL. These systems were not designed to deal with the huge amount of data we have today. Data keeps growing, and the amount of time we spend on data preparation before we even can get a report just keeps growing and growing. Maintaining and upgrading these systems is very expensive. Let's take a look on the problems. Why is it so challenging? Let's say I'm a bank. I have few data sources. I have my customers. I have the transactions that the customers are doing with the bank. I may have the physical locations that the customer is right now. I have the activity the customer is doing, and who knows what is coming next. Now you have few pipelines. Every department wants to get out of this data more. Marketing says, I want to see, to better understand the customer, to get what we call 360 degrees view of the customer, to give him a multi-channel environment. Fraud department says, I want to enrich the data. I want to be able to identify frauds very easily. Okay? Compliance and the government and the regulations are telling you, please create another report and another report. And the customers are meeting pains. The pains that they meet is performance, slow and stuck processes. They try to run the process overnight, but sometimes by the morning, the process is not ended. So they have to stop the process because they don't want to bother the users. Size. Customers are analyzing 10% of the data, because if they try to analyze 1 full year of data, the system gets stuck. Or the report comes after 1 week. The results of the report arrives after 1 week, where there's no meaning for the data anymore. The cost. They try to solve the problem by buying more servers and developing more code, and it just gets more and more complicated. So what we see is that extracting value of big data is not that simple. Most databases currently cannot keep up. The cost is high, time to value is long. You need a lot of knowledge, many technical resources, and many technical barriers. We meet customers, and I'm talking about the largest customers in the world. They have as much time and money they want in order to invest, in order to get the reports running. No matter how much money they put into that, they cannot get the results they want. It's not a matter of money. It's a matter of technology. You can see here when Oracle, DB2, Teradata, and alike were developed. And you all know how much data was in the world back then and how much data is in the world today. This is the reason these systems cannot keep up. This is the reasons people are patching up these systems and are trying to find new ways to squeeze every value they can get out of this data, but there is a limit. And that's why 90% of business intelligence is lost, because customers decide to analyze only 10% of the data. And if you see on the left here, this is data from the USA. You can see how much of the value in the data is captured. And you can see that for most organizations, they get the value of, they analyze 20 or 30% of the data they have. They are losing a lot of business opportunity, and the amount of money they can make if they can analyze more data faster is huge. The investment is worse for them. The funny part is that this problem is not going to go away, because if you have today 1 petabyte, next year you will probably have 2 or 1.5. Data just keeps growing. And the more data you have, less % of it you can analyze. So the problem is just going to get bigger and bigger and bigger. Not only you will analyze less data, but the amount of data you will have will just keep increasing. Okay. Why existing solutions are not good enough? Basically, most of the customers have chosen one of the two following strategies. Either they bought appliance like Teradata, Exadata, and alike, or they use the Dupe environment, which was a very cost-effective way to store the data in many cost-effective servers and distribute the data across the organization. The challenge with Hadoop is that it's a great file system, but it's not a database. It was not designed for analytics. It was not designed to create reports. It was not designed for big data. It's a very complex environment, and in order to run it properly, you need an army of developers. You need a variety of technologies. You need to maintain hundreds, if not thousands, of nodes of servers, and the result is that it does not meet your queries. We meet customer after customers who have Hadoop in clusters, huge, hundreds and thousands of servers, and they tell us we just grow and grow and grow and we add more servers and the complexity doesn't end because our data is spread across is distributed across many servers, and when we want to make analytics simple, it's not happening. When you're talking about Teradata and Exadata, they're very expensive to start, very costly. Compute and storage are linked together, and they are very inflexible solutions. So far, I described the problem. What challenge are we trying to solve? How do we solve it? We help customers achieve more, better, faster, and what we like to call previously unobtainable business and operational insight. With one server, we can compete with 100 servers. Instead of looking for your data in 100 different servers, you can query one server. This will make the query time 100 times faster. Our value proposition is very simple. Get more business insight by analyzing much more data. Focus on the business and not on the technology. Make it cost-effective, much faster, and with a very, very small footprint. Now we need to show the marketing slogan. From the marketing point of view, we say you can analyze 20 times more data, run every query 100 times faster at 10% of the cost. I emphasize this is a marketing message. However, if I show you real results, from a POC, we can see the following. This is the real results from a POC versus Oracle. You can see Oracle analyzes, 3 hours of data. It takes it about 20 minutes, while Sqream analyzes 2 days of data. It takes it 28 seconds. So the ratio is 1 to 150. Imagine that instead of waiting 150 minutes, which is more than 2 hours, you get the report within 1 minute. By the way, this POC was made by a manufacturer who makes iPhones. And all these logs are coming from machines who create the chip for iPhone. So for them, if they can understand that the manufacturing, something is going bad in a minute and not manufacture 500 iPhones which has a small defect, the value is huge. The nice part is that when they try to run analytics on 10 months of data, because they have manufacturing floor and they want to take a lot of data for 10 months, Oracle is not able to do it. Sqream can do it in 6 minutes. It's a huge difference. Now this customer has Teradata, this customer has Oracle, this customer has Hadoop, has all the money and technologies that he wants. Okay? You can see another query. Instead of 42 minutes, 60 seconds, which is 1 minute. The difference is huge, especially when you have thousands of consumers of the data who rely on this data to make decisions. And instead of waiting 1 hour, you have the ability to know what's going on within 1 minute. Very powerful. Okay? So this is a marketing message, but sometimes we are much better than the marketing message, just like we saw in this example. Okay, how do we do it? Number one advantage that we have is derived from the fact that we are powered by GPU. NVIDIA GPU is a very, very powerful device, okay? It has a very fast memory. It has each of the GPU has 5,000 cores. So we are able to utilize the 5,000 cores and the very fast memory in order to do analytics and run SQL queries very fast. Another huge value is that the GPU help us to get data in and get data out very fast. We usually say per one GPU, we can get 2.5 terabyte per hour. So if a normal server has 4 GPU, we have about 10 terabyte of data coming into our database. Very scalable. From 10 terabyte to 1 petabyte, all you have to do, add storage, add GPU. No need to change any code, no need to change anything. Just add a server, storage when you need, and run your queries, okay? Another beauty of our solution is that we are fully compliant with SQL. Any query that you currently have, you can run on our system. No need to change. Copy and paste the query, it will run on our database. Let's see step by step. So first, the GPU. Very fast to get data in, very fast to get the data out. Every GPU has about 5,000 cores, and the memory is 900 gigabytes per second. Very fast. Once we can get the data into the GPU, we can manipulate the data, and this is how we get the queries run 100 times faster. Another huge benefit that we have is because we are not limited by speed, we can compress the data on a factor normally 1 to 5. We don't have any penalty that we pay. When you have a normal database and you compress the data, it means it consumes a lot of time. Because the GPU is so fast, it doesn't consume any time. So we can compress the data very fast. Another beauty is that we can collect metadata. This means we will not need to do index in order to get reports. Once we get the data in, you can run any query without any data preparation at all. Okay. The way we work. Sqream starts with raw data, like any other database. First step is we make the data we turn the data into columns and create metadata. Then we break the data into chunks, and each chunk, based on the content of the chunks, is being compressed separately. The goal is to get to a very high compression rate. So if we compress text and numbers, we choose another methodology. We have 6 different methodologies to compress the data. After that, since we run the query, since we collected metadata, we can now do data skipping. So if I run a query, I want all the people in Tokyo who graduated from university, that their age is about 50. So I can take only the relevant chunks. This is just like indexing, but I did not have to do any indexing. While I import the data, I collected metadata, which will serve me as the index in the future. We load them to the GPU, the relevant chunks, and we show the result. All this process is being done with no need of any technical skill. Okay? So the process is automatic, no need for data preparation, and immediately the end users can consume the data. This process minimizes the time to analysis, eliminates complex data pipeline, and addresses poor scaling of traditional solutions. You can consume the data in your preferred BI tool, like Tableau, for example, without PU computation, aggregation of the data, materialized view, or cubing. Take the raw data, start consuming it in your BI tool. All this process is eliminated by Sqream. Here is one example. This is a customer we have in Thailand. This is a telecom. Before he worked with us, he had a process of getting CDRs, called data records, from 3G and 4G antenna. It took him about 1 hour to prepare the data before the business users can consume it in TIBCO. After we implemented our solution, it takes him now 46 seconds, let's say 1 minute, to consume the data. Everything is automatic. It streams the data from the antenna into Sqreams, and immediately the users can consume the data. This is very important because now we can change advertisement. He can see that in a specific part of Bangkok there are many young people, so he can change advertising to jeans. He can see that there are many people in a different region, he can change the commercial. Another thing that we have done is we've decoupled storage and compute. You want to add more power, just add more GPU, add servers, and all of them are connected to one shared storage. It makes it much easier to query when you run to one specific place, if your storage is fast enough, and very easy to manage. We like to call this system very compact size, huge power. One server with 4 GPU can hold 100 terabytes and will replace the 42U legacy data warehouse racks. Very small footprint, very powerful, and provides a 100 times faster results. Scaling is very minimal in terms of cost, performance, hardware cost, and complexity. You want to scale up, all you have to do, add GPU. No more room for GPU on the server, add a server. You need more storage, add more storage. Very simple. I don't have a lot of time, so I will jump to one last case study. Okay. Okay. This customer is an edtech company. They used to work in a Dupe environment where they ran queries that used to take them, after the whole process, 5 hours per query. These queries are their daily routine to make money. The first implementation we've done there, they were using hundreds of Hadoop nodes. The first implementation we've done there, we minimized the 5 hours and it became 5 minutes. Big difference. Big difference. Now, the beauty is that when they saw that we can give them results so fast, they said, okay, let's do the following. Let's add more data. And they send us, instead of, they send us 4 times more data. Okay, instead of 85 terabytes for the query, 360 terabytes. The time remained 5 minutes, as you can see. The query time did not change. And the reason is that all we had to do is add more GPUs. So the query can run much faster. Now, in their Hadoop infrastructure, no matter what they did, the queries did not return anything. It was too much data to run this query. So you can see here a good example of 2 values. One is the ability to get a reply within 5 minutes and not 5 hours. And then the ability to put in much more data, 4 times more data, remain, again, get the reply within 5 minutes, and be able to benefit the system. Okay. Last example, I have two more examples. This is a big bank in the UK. Fraud detection use case, okay? Data enrichments and use statistics to discover new possibility deviation in purchase and possible frauds. Dupe as a file system and Spark as the data processing unit. Basic everyday work is to add more statistics based on existing data in different distribution point of view. Statistic on purchase based on time, on product, on location, and the like. Complex statistic each time will require different data distribution and very complex daily operation. In this case, you can see one server competed with 20 nodes of Hadoop. When they started to add and ask more complicated questions because they wanted to better identify fraud, Hadoop and Spark were never able to finish the query. With Sqream, 65 minutes, which is a long time. It means the query is very, very complicated, a lot of joins. With Sqream, we were able to finish it and complete the task. Thank you very much.